Hi, good afternoon. Let's get started. The video. Okay, so there's only one other multimedia technology that we haven't looked at, which is games. I think games are a lot more interesting in some sense. You know, games are very popular. People are trying to use games for other things beyond gaming, right? So games is not just for sort of wasting time, but the virtual reality and stuff. People are trying to use that for having conferences and chats and all those things, like virtual worlds and things like that, right? And it's a form of interactive communication, mass communication that we don't see in other technologies we looked at, right? So in terms of doing a video and audio and all those things we looked at, basically the idea here was to send a movie or something to one user, and having more users is just basically I just scale it to set a different number of users. Whereas in the games, everybody participates in this one thing, and you can have large number of people, right? So there's a lot of statistics about the second world and all those things having millions of players playing at any one time. So you get the scale effect. How many of you are active network game players? And what platform do you use? Like PC or game consoles or PCs?
Xbox 360.
Game console kind of thing. I'm kind of surprised that so few of you actually play network games, right? At least in this course, it's perfectly okay for you to say I play a lot of games, because they probably appreciate some of the issues involved, right? So I want to introduce a little bit of those things. There's a lot of issues involved in the games, and it depends on what type of games you're playing and how the business model is, right? So my understanding is there are lots of game developers, but there are fewer game server people, and they're not like they don't have the Google effect, right? Google effect to me means that here's a company which has almost infinite amount of money, so they can solve the problem without having to worry about whether it's financially viable at that particular instance. So they can build something, deploy it with no concept of whether it's viable or whatever, right? Whereas these companies are there to make money, so they want to get subscription dollars from you. So I'm told they cost like any of you subscribe to those gaming services? So I think that they cost like $10 or some odd dollars a month kind of stuff, right? So they can't afford to do something which will get you to leave the system, and they can't afford to buy infinite amount of bandwidth and stuff. So they really have to worry about how to make these things, how to deploy these things without having the massive infrastructure of big companies and stuff. So there are a lot of issues on how to do peer-to-peer and all those things. We'll see some of those in due course, right? So in that vein, I'm going to probably put a survey on the Vista, our course management system, to see if there's any topic that you would like me to kind of look into. So I think by this time you should have some sense of what multimedia stuff is. I would like to see if there's some particular topic you would like to me to focus, because there's a whole bunch of issues. I'll give a list and say, maybe you can choose one of those, right? And there are a lot of schools which are beginning to offer computer networking as a full-time major, equivalent to computer science and stuff. So there's a lot of interest in terms of academic institutions teaching computer networking, both in terms of networking and operating system issues, and also in terms of the game development and arts and film kind of stuff, right? So there are different kinds of games. There's first-person shooter games, and there's a whole slew of these stuff, right? Unfortunately, I don't play any of those, but each one of them have different set of constraints, right? So I think a little bit slides later we'll show a little bit about some of these things. First-person shooter games, my assumption is you're trying to shoot somebody, right? And you're trying to shoot somebody with a gun, right? So the implication of that is you're trying to shoot somebody with a small projectile, not like a really big projectile, which means that I need to know precisely where you are, because if you move a little bit, then the bullet may not hit you, right? That has a big implication of how these things are played when you're on the network, right? And the particular author is working on latency kind of issues, and that has implication on those, because depending on how accurate you have to be where I see you. So the essential thing which is happening is you are in some part of the world, I'm in some part of the world. We're both playing. I can see you, you can see me, and I shoot you, and you are somewhere, right? So our view of the world has to be precise enough because the projectile that I'm sending is fairly small, right? So if I'm shooting you where everything in this room would get polarized, I don't have to really worry whether you are where you are, right? So your movements, even if it doesn't come to me that accurately, I'm sort of okay. Whereas if it's a first shooter game, I need to know precisely where you are because maybe you're trying to avoid me, you're trying to run. So we have to make sure that the latency is very good, right? So in those sort of games, it's not as important that you look pretty and stuff. All you need to know is where you are exactly, so I can do the right thing. You have to know where I am, so you can duck, right? So you don't want to get to the case where you don't see me because my updates haven't come to you, kind of stuff, right? Whereas there are other games where you build virtual worlds and where the realism is far more important than this kind of stuff because you're building a, say, a house or something that you're sharing with somebody else. You want the realism of what you're trying to do be applied to the other people. And there are now more and more of the sort of things we'll see later on in terms of chats and audio with these games, right? I don't know how many of you played those kind of stuff, but the assumption here is you form a team to kill somebody. So you're trying to form a team among your friends, and you want to do this stuff. And the goal is you want to be able to talk to your friends, either through in the virtual world some sort of walkie-talkie, or just talk to each other, right? So you want to be able to talk to and figure out a strategy to destroy the opposing team and stuff. So you could either do text chats, right? And again, those text chats add a lot of importance because whatever I'm typing should show up on the other person immediately. But more naturally, you want audio because audio, then you don't have to type. You can focus on shooting, I guess, right? So that adds lots of stuff because they found that people really like if it's spatial audio, right? Not monochromatic audio, but mono-aural audio, but actually a spatial audio, meaning I know precisely. So if my partner is here, I would like the sound to look like it's coming from here, right? If my partner is way over there, I would like the sound to sort of look like it's, I would like to get a sense of how far my partner is because that adds realism, right? And I would like to get a sense of how far things are. So I would like to know in 3D where I am, right? So even though the things I mentioned before that audio is not that resource intensive, once you add this sort of a notion, right, it means that whatever they're saying, right, whatever my friend is talking. So if I have two of my friends here and I have an enemy over there, I would like to hear my friend who's here talk as if they're talking from this side, and the distance to be reflected on the sound. So when they walk towards me, it gets louder. When they walk away from me, it gets different. So that adds more processing that taxes these systems, right? So if you can do this right, then you can actually feel like you are in a real battlefield or what have you. If you get it wrong, then it's very annoying, right? So if your audio sound looks like somebody's like really close to you, but in reality they are pretty far, then you would tend to do the wrong thing. So there's lots of issues with the added by the video game because things have to be really quick and things have to be realistic. And people are willing to tolerate the quality. They don't want high fidelity and stuff, but they expect the latency to be good, right? So the latency comes in part because of the nature of where these things are. Latency, in a high-level sense, is the time it takes for you to talk to the other person, right? So the game may directly let those two people talk to each other, or it may go through a server. More likely, it goes through a server. So the time between you and the server and the other players becomes very important, right? And in general, this is important for most other stuff. So when you go to a web document and stuff, you want it to come to you from a fairly close location and things like that. Whereas in the games, it becomes even more important because the latency is very important, right? So, in the web case, I would like to get the document from, say, South Bend, maybe Chicago. But if I have to go to Tokyo to get a document, I'm not going to feel too bad about it because it's probably going to add maybe half a second longer. I may be okay. But in this case, if it goes halfway across the planet, then my gaming experience goes down. And they found that people are able to tolerate certain aspects, but once the quality goes beyond certain things, it becomes so unplayable that you just tend to leave, and that's not a good thing, right? So there's a little animation, I guess, on how to get these packets across, right? And so if you take a networking course, other place where this is important is in terms of internet TV, right? For a number of reasons, internet-based TV stations are not popular in the US, and my sense is most important is the copyright issues, right? How many of you watched the Hulu.com? So what do you think of it? It's good quality, right? But Hulu basically tries to be fully controlled by the TV studios, and there's not much of I mean, they have a very good business model and all those things, so they don't have to involve you and me in terms of being a peer-to-peer aspects of it, right? But what you would really like is to have some sort of a peer-to-peer infrastructure where I can do what Hulu can do on a much smaller basis, right? So I don't have to be NBC. I can have a small TV station or some program. I should be able to send it through the stuff, right? They're extremely popular in China, right? And for some reason, China, I think there are a few companies like PP Live and PP Ants, and there are a few Chinese programs, right? And my impression is they usually have 3 or 4 million customers online at any one time. So they're building this massive infrastructure using the internet to broadcast the TV stations. Then there are other stuff in Eastern Europe and stuff. Nothing much happening here, but in terms of the numbers, it's pretty staggering because there's a lot more of this happening in China and stuff, and even they have to worry about the same kind of issues in terms of how to keep the things local, and we'll try to see some of those. So there's a lot of effort in trying to make that happen. The other aspect is in the IPTV, the AT&T US and stuff that I mentioned, where it's still AT&T is trying to give this TV to you, but they still want to use some sort of a peer-to-peer aspects to make things more scalable so they can make more money and in some big sense give you some more kind of cash back, right? So the idea here is they would like to sort of use their own customers to build, to stream the video. So even there, you have to worry about these sort of issues of latency and all those things. But again, games is the one where everything comes to a, because very obvious, because if you don't get the same quality, you have to leave because it's interactive. All the other ones I'm talking about is not interactive, right? So you're watching a TV station, you're passively viewing that, so you're not going to complain if it's slightly delayed and stuff, right? So the slides give a number of issues of what happens if your latency is not good enough. The first thing is it affects your responsiveness, right? Which means that when I do something, I want to get a feedback of what I did, right? So I can give a local feedback of what happened, but you would like to have it go somewhere else to get a feedback that everybody globally knows, right? What I'm saying is I may get a scene of what the scene I'm playing, and if I'm shooting something, I want to shoot something, and I want to get a response back saying what I shot is dead, right? My local system would know what happened because it has a view of the world, and it knows where my bullet went and what happened, right? But what I would really like is some sort of confirmation from somebody saying what I did really happened, so that everybody else knows what happened. Which means that it will have to go to a server or something to say, okay, I shot a bullet in a certain direction. There was this human being in other direction at that location. That means I think that person should be hit, and that person should think that they got hit. So those things have to happen, and those are affected by the latency because if it takes me a long time to reach somebody, then they may not know that they're dead, and they may do the other stuff, right? So one of the game they had was, in a football game, right? So if you're, I don't know how this particular game is, but apparently, the player is running towards the left, and at some point, you want them to not, stop going left and then start moving up, right? And you would like to make them go as far as possible. You don't want to be conservatively not let them go all the way. And it may so happen that if it's not responsive enough, then the player will keep going to the left, and but you didn't, you were saying something else, but the system is behaving that far, right? So you have a very small tolerance for this sort of a thing, because if you find that you can safely only go to here without actually having this overshoot effect, then you're basically curtailing yourself to a smaller component of the football field. So your experience is not going to be as good because you're not really playing the game. You can't really push it all the way to the extreme, right? It affects the consistency of what people see. So again, it's from the same game. So I don't know if you guys play, you probably realize this, but essentially what happens is the video is really bad, right? But there's a player here, and I guess that's the player that I am or something. So that player is moving across the field. So in my view, the player is here. In the other person's view, the player is sort of here, right? So you want the consistent view across all the things because you want everybody to sort of know the same thing. Because if I believe the player is here, and if you believe the player is here, you're going to do different stuff, right? And depending on what you're trying to do, you may do different stuff than what I do. Then the more we diverge, the more things become different, right? So I'll be playing a different game than you'll be playing a different game, because I'm here kicking somebody and you're kicking somebody else, and the whole thing kind of falls apart, right? How would you solve, without going into details, how would you solve this if you were a game developer? How would you make a system like this consistent, where everybody sees the same view of the world? This doesn't have to be complicated, but naive approach of how would you solve this issue, right? So what is happening is there's a player here, there's a player here, and let's say a simple case, there's a server, right? And for some things to happen, I have to send my state, what I'm seeing, to the server. And this person has to send the state to the server, and the server has some sort of a communication back, right? So if I take one step, I can send it to the server saying I took a step on this way, and the server would have to send it over to this person, right? Get confirmation that they also know that I took one left step, and then they acknowledge back saying, yeah, I did that. Then you can send a confirmation back to me, right? So every step I take, everybody agrees that I took this step, right? So basically, I take a left step, I say I take a left step to the server, and the server tells everybody he took a left step. You all agree that I took a left step, and then I go on to the next step, right? That's one way for me to make sure that whatever I'm doing is delivered to you, right? Would that solve the problem with this game? Everybody else is also playing, right? So I'm not the only one who's doing this, right? What other issues would happen if all I'm doing is, yeah?
You'd have to slow everything down so there's time to send, and then send it to all the other players, and then for the players to respond. So you'd be basically, it would look like a laggy game.
Mm-hmm. Yeah. And while I'm doing this, right, while I'm stepping, right, you can't step either, right? So if I'm taking a left step, if the way I talked about it, right? So if I'm doing a left, right? Suppose you did a right here, right? Independently, right? Not by me, right? So with the simple approach I said, where whatever I'm doing has to go to everybody, right? And this person does right, they send it to everybody, right? That still won't solve the problem of what's going on, because the ordering matters, right? So if I'm taking a left and you're taking a right, they happen in certain order, right? And the order matters because it may, I don't know how it matters in this game, but it may matter in some game, right? So maybe we are going into the same spot. So you have to make sure that the ordering is the same across all of them too, right? Not just the fashion of what I did should be known to everybody, but the order in which we do has to be globally serialized, right? You may have heard this word from operating system or distributed systems and all those things. So essentially the idea here is you want to make sure that everybody sees every action in the same order, right? Otherwise, you may see me taking a left first. You may see somebody else taking a left first. So even though both of us are eventually going to see the left and right action, you want them to happen in the same order, because otherwise things get messed up, right? So the solution would be what you kind of pointed out, which is slow the whole thing down, so the server can say, now somebody, now you can move, and nobody else can move anything till your output is sent to everybody, and then you get the response back, and then I say, okay, now you can move, and then now you can move, kind of stuff, right? And as you can imagine, this game would be awfully boring when everybody has to agree on every little step, right? Especially since some of these players are operating in dial-up and stuff, so you cannot play these games, right? So you do want to let these things be inconsistent, because the simple way of making it consistent is not going to work, because you have to make sure that everybody sees everything in the same order. So you have to let things be sort of inconsistent. But the challenge here is, how do you make it inconsistent and still make it interesting, right? And again, naively, how would you solve this sort of a problem? What sort of techniques do you think would solve that kind of a problem, right? The problem here is, I want to send the global state to everybody. Everybody has to agree with what I'm doing, right? Can you think of some mechanisms to sort of localize the effect? Do you understand what the problem is, right? So I want everybody to get my state, and I want everybody's state to be known to me. So it doesn't scale, because everybody has to have their state known to everybody else. Is there a way to sort of localize the effect? So the answer key is the localize, right? So if you can localize this stuff, you may be okay, right? So the localizing part is, depending on the game, there may be something that the player cannot possibly do, right? I don't know much football, so bear with me. But so if this person is sort of kicking from here, right? It may be the case that whatever those two over there are doing may not really affect what these people are doing. Meaning, if whether the last player, whether it's over there or like slightly over here, may not really affect what's going on here, because this is center of action. It may matter to them because they're both like trying to jostle for space, so they may have to worry about what this is, and this may not happen what it is. So one of the ways to sort of solve this problem is try to, depending on the game, create different spaces where people within the space would be very consistent, people outside the space is not very consistent, and it doesn't matter because you probably don't worry about those things, right? And that's one of the ways you get scalability. And as you can imagine, it gets fairly, it's not as trivial as you would imagine, because this person can throw the ball all the way across, and then suddenly the action moves to another one kind of thing. But you try to do something like that, and that's some of the things that we'll try to look at it from a higher concept, but that's the problem, right? Keeping these things consistent is very, very important. Keeping this consistent is very hard. You have to try to solve them, because otherwise these sort of games are uninteresting, especially when you have these virtual worlds with 2 or 3 million people. That's a lot of human beings who are creating lots of stuff. So you want to make sure that they're all consistent, because otherwise you have, so people who are playing this are not exactly supposed to be computer scientists. So you want them to have an experience where whatever they did seems like it's what everybody is seeing, right? So the other important aspect is the notion of fairness, right? All the games, there's people who want to cheat, right? The notion of cheating in games it's a separate research field all by itself. There are tons of publications on how to prevent cheating, all those things, and companies and all care about this, because as long as people are cheating in these games, the games become completely uninteresting to the other players, right? So if I have to go into a game, so if I, for example, play that football game with one of you, right? I'm going to lose, right? Because I don't know how to play the game, so I'm going to lose, right? But I would like to lose fairly, right? I don't want to lose because you know what the rules are, right? If you have advantages that I don't know how this game is played in the virtual world, then I will get so dejected that I'm not going to come back, I'm not going to play, I'm not going to spend the money. So companies don't want that. So they want to prevent cheating. right? There are lots of ways of cheating. One is me understanding the system enough to cheat. Then there are other ways where you probably heard of this stuff, where I hire people in like South Korea and all those things to play on my behalf and accumulate all the points and then sell it back to me for real dollars, right? You probably heard of those stuff, right? There are apparently people actually in South Korea for some reason who play games on your behalf and sell the credits back to you for real dollars. And you hear the stories of somebody dying after playing nonstop for 3 days and 5 days and all those things, right? So that's a form of cheating, which is kind of harder to fight against because this is an actual human being playing and selling the credit to you. But what you're more about here is in terms of somebody using the system to cheat, right? So one simple way to do that, which sort of ties into the consistency notion, is if somebody is too far network latency sense, then I have an advantage. So if I figure this out, if I figure that you're pretty far in the network sense, so if you both try to shoot at the same time, I know that whatever the server sees is what really counts. So I can shoot slightly later than you and still win, right? So in this case, they're looking for some sort of treasure. Whoever finds it first is the one who wins. And since the speed of light dictates that it takes a certain amount of time for you to go from here to here, so the server says there's a treasure, go find it, or something shows up on your screen, you have to pick it. By the time I see it, I pick it. They both, let's say, picked at the same time, are actually, right? And because of the network latency for the message to come back, right, they might have done it as soon as they received. So this user might have done it faster than the other user after the visual was shown on the screen. But because the message was taking so long, right, this person could be slow and still win the game, right? And after a while, you kind of get frustrated because the instant it shows up on your screen, you went for it, but you never get it because somebody else who's away from you is getting it, and you want to avoid those kind of systems, right? And these are classical distributed system issues, but they become much more harder because you have an actual human being who's perceiving these things, right? Whereas in a system like if you're talking about grid and cloud and all those computing, it's not interactive, so you have a lot more leeway on how these things are done. The other aspect is the precision. Again, depends on the precision of the task, right? And the higher the precision, the more these things become important. Like I pointed out, if you're shooting with a bullet versus shooting with something which kind of takes out the whole area, right? So you might have, if you play these games, you might realize that some of these tools actually are not very precise, right? You may see that this particular weapon kind of like takes out the whole area, right? It sort of takes out this whole kind of space, right? It may look good from a game perspective, but from a technical perspective, bullets are very hard to deal with because they take a very narrow path. So unless you have very good network latency, bullets are very hard because the task is, the thing which I have to project onto you is so small that if there's a little bit error between where you think you are and where I think you are, then the bullet will just leave and you would not get a kill, right? That doesn't prevent you from playing these things. So in many cases, if it's not really precise and you get a kill when you shouldn't have gotten a kill, or you don't get a kill when you should have gotten a kill, if it sort of balances each other out, you may be happy, right? How many of you played these kind of sort of games where you thought you should have gotten one, but you didn't, but then the next round, you get the credit for something that you don't think you should have gotten one, so you kind of convince yourself that these are all kind of even out, right? So as long as they're sort of even, you're kind of okay, right? I mean, because we're not trying to be a marksman on these things, but you have to be aware of this. So, depending on how far this has to be. So in the first case, you have to, the person has to be within the certain area, whereas in the next case, they have to be within a lot bigger area, so I can send a lot more errors, right? It also depends on the deadline of how fast you have to do. So if there's a lot of, if you have to go through these little patterns to get somewhere, then you're willing to forgive the fact that it's not latent, there's not much latency. So in some sense, the game developers add all this stuff into the game. So you never have a very straight line, where you can get, because then it's obvious to you what's going on. If you have to go through this little stuff, then you're not going very fast, so the latency is not obvious to you, right? So they have a graph. So the particular author had a graph on how these different types of games are, and what's the precision, and how the latency and all matters. So the different sort of games have different precision and different deadline, right? So some of them are tighter. So if you're doing a shooting sniper kind of game, the deadline is pretty tight and the precision is quite high. So if you're playing those kind of games, then usually you get rid of other components like how clean the world looks and stuff. Whereas something like the Sims world kind of thing, where you're exploring worlds, it doesn't have to be very precise where you are, and it doesn't have to be, the deadline is not very, very high. So if you're doing a virtual world where your goal is to talk to another virtual character, right, you're willing to tolerate a lot more stuff, because it takes a little bit of time to, you want the realism of seeing your friend, not exactly where exactly they are, and things of that nature, right? And so so they had some graphs on how these things are. So these are very important kind of topics in parts of computer science where people are trying to address these issues, because these are really big stuff, right? And so I think I mentioned this before, and apparently games are really, really popular in South Korea, where all the kids go from school, 3 o'clock from school, go home, and start playing till like 2 in the morning sort of stuff, right? So when you talk to folks from South Korea and stuff, they're like, you don't know what you have in terms of teenagers here, but it's really bad, because you have to get, so they're very social in the virtual world, but not in the real world, because they all go to play, right? And so some of the ways, one of the things that you pointed out is, one of the ways to solve this stuff is to delay everything, right? And again, delaying everything would solve the problem, but make the whole game kind of slow, because essentially now you are restricted by the person with the most delay. And you don't get the good experience based on what you're trying to do. So you want to make it not so bad by relaxing some of these constraints while still making it interesting enough to play, right? And they also talk about some of the games, they do a rollback, right? So they let you move forward, but then if you find that whatever you did had inconsistency, you have to roll back. So if you're running somewhere, I let you run, but if at a certain point I had shot you, then if the information comes to the server, it may tell the other player to say, even though it looked like this person had gone up to this point, roll back, because they got shot here, right? In your side of the game, it looked like they could have gone this way, but the other person at this point saw you and shot you, so I have to roll back to where this part was, right? So if it's like this far off, you will notice, right? You look like you kind of walked up here, and then the game kind of rolls you back, and then gets you killed, right? But if it's small enough, then you may not notice it. So then I can actually let you do whatever you want, but I keep rolling back to a consistent state across the different games, right? And again, if I do it acceptable enough, then you won't complain. Otherwise, you will complain, right? Right. So that sort of gives you an overview of these technologies, and you would realize that there is no single set of constraints. I mean, everything depends on what you're trying to do and what is your goal, right? In terms of a video, I can send very high quality, or I can choose small quality. So depending on what you're trying to do and all those things, the whole thing changes, right? And that's what we will look in this course. So from this point on, I'm going to look at start with the other textbook, right? In terms of networking and all those things and how it affects these things. I'll try to add in more of the topical issues which are not necessarily in the book, right? So first we'll look at networks. and how the multimedia technologies we talked about affect these things, right? So naturally, I'm not going to go through the whole networking stuff because there's a separate course that our own department which teaches those things. I'm just going to give a high-level overview of stuff that affects what we're trying to do, right? So one of the things that you would have, if you've taken a course, and how many of you took a course in networking? Few of you, right? I guess for the operating system, at least people in computer science should have taken an operating system course. Networking is not required. So the idea here is you might have heard about there's two kinds of switching in computer networks. One is a circuit switched and one is a packet switched, right? Circuit switched, you kind of establish some kind of connection between the endpoints. And then once you establish endpoint, you have the link all to yourself, right? So one of the classical examples is the classical telephone line. Right, the old-time telephone line, where when you make a phone call from point A to point B, there is a link between point A and point B, which is there throughout the duration of your call, right? So, and being a telephone line, it gives you a certain amount of bandwidth. So it gives you like 4K or whatever the thing we talked about for audio communication. So you have that channel all to yourself. You can use compression to make the quality better or what have you. But you don't gain anything by making the amount of bandwidth you need small, right? For example, if I do a silence detection and find out that most of the time you are silent, right, which is what happens in telephone conversation, right? So either one person talks, other person talks. Very rarely do both the people talk and expect anything to happen, right? So you have one person talking while the other person is listening. So there's not much data going on the back end. So if I do a silence detection, and notice there's no talk on the other end, right? There's not a whole lot I can gain by that because I have the dedicated channel all to myself. So even if I don't send anything, I still pay the same amount of stuff, right? So most computer networks are built on the notion of a packet switch network, where the idea here is I break the conversation into small packets. Each one is independently routed from the source to end, right? So that gives me a lot more options. So I don't have to set up this connection. I don't have to wait for the connection to be set up before I can start talking. And the negative part is every packet now has to figure out where it has to go, which means every packet has to keep some kind of a header to show where they're going. So it adds overhead of packet size and stuff. I mean packet header, right? But the flexibility is everything is finding its own way. So if instead of talking at 4K, if I suddenly start talking at like 8K or some high fidelity conversation on a telephone line, then if there's enough bandwidth, I could potentially use those. If there is no conversation, then I can do dead space detection and not send anything at all, right? So I can change the network bandwidth that I'm consuming depending on what my true needs are, rather than establishing this sort of a stuff, right? So the most modern computer networks are essentially packet switched and not circuit switched, because circuit switch is wasteful because you have to establish the whole thing. And for most cases, things are varying, so you go with the packet switch, right? So this is something that you would have started, I guess, on the first day of networking class. And so the idea here is you want to use packet switch networking, where everything gets routed, right? And packet switching is not really good if the packets are very small. If you're sending 1 byte packets, then your header is going to be pretty big, and each packet has to figure out how it gets from point A to point B in whatever routing you kind of mentioned. So you pay all this overhead for such a little kind of amount of traffic, right? The assumption that you do in a packet switch network is the amount of traffic you send is large enough that you would not be sending these sort of small packets, right? So for example, if you consider file transfer, right? If you're transmitting a 1 gig file from point A to point B, then I can, even though I have to use this header, I can amortize the cost, right? So for example, I can send a 1,000 byte packet, and if I have to use like 40 bytes of header, the overhead is 0.4% or what have you, right? So the assumption here is I'm going to be sending lots of data. I'm going to doing bulk transfer. So the flexibility of me being able to get however much bandwidth there is at that particular point far outweighs the notion of having to worry about the header, right? And as we will see, that need not be true for multimedia kind of traffic, because multimedia traffic, it's not about data transfer, right? It's more about how me being able to send certain things at a certain time. So if I'm sending like 30 frames per second, I may have to send some data every 1/30th of a second, but I cannot be ahead of the pack unless I'm sending a saved video. So if you're doing a video streaming, if you have nothing else to send, right, I cannot send some video from the future because future hasn't happened yet. So I need something in a constant fashion, right? So in multimedia sense, I could probably use something like a circuit switch stuff because I'm going to be spending something a lot into the future. I'm going to be sending something way into at sort of the same rate that you're getting right now. So I could live with the circuit switch model, right? Circuit switch model fits better with multimedia kind of network than packet switched, and we will see where they cause problems and whether we can do something about it, right? And so these sort of issues are not really stressed in the networking community because networking community, if you're trying to send something, if it's not really streamed, if it's a bulk transfer, you don't really worry about all the stuff because you want as much as you can get. Whereas in this case, I don't really care about all the stuff. I want a certain amount of bandwidth. I could use some more if you have them, right? But I'm going to be using this sort of thing constantly, right? So I would rather have some sort of a guarantee of how much I can get, and that is kind of harder to achieve with this model, and that's where they intersect, right? And sort of there are two types of network protocol that you would have heard. Within the packet switch network, there's a TCP and UDP, right? TCP, so they're kind of like that. They're opposed to each other. They offer more features than, so you cannot mix and match either of those. So TCP offers you reliable, in order, at most delivery, right? Which means that whatever you send on one end would be received on the other end, right? So if you're having communication with somebody, whatever you send from one end is guaranteed to reach the other end, right? Unless there's failures, right? And it's in order, meaning the order that I'm sending to you is the order that you'll receive it, and it will only be it's guaranteed to be delivered to you at most once, right? So if there's a failure, you may not receive the packet. So if I'm sending a lot of data to you, right, TCP will guarantee that you will receive them in the order that I sent. You'll receive them only once, and you will receive them reliably, meaning like none of them will be lost. If I'm sending like 1 through a million, so you'll receive them from 1 through a million, so what it does, so it's really good for certain sort of applications, right? It's good for applications where, like for example, if you're doing a file transfer or something, this is really good because I want to send the whole file. I just write the whole file into the network, and eventually it'll come to the other end, right? Even if this network, something gets lost, TCP guarantees me that whatever was lost it'll internally retransmit by itself and deliver it to you in the order that it was sent to you, and life is good, right? Except in the case of multimedia, we have constraints on when things should happen. So if you're thinking about a game, I need to know when things happen. So even if I lose something, I would rather not wait for the packet. I would rather like to move forward, right? So if I'm watching a TV or something, if I don't get one frame, right, I may be able to move through that. So if I don't get the B frame, I would lose one frame. So what's the big deal? I mean, I can kind of move forward, right? If I don't get an I frame, I won't be able to decode the whole the group of pictures beyond that. But in a lot of sense, I would like to have that control by myself rather than what TCP or something would force me to have. So I don't want to be sitting there waiting for TCP to do all its stuff. I would like to have things under my control, right? So the initial feeling was TCP is not a good protocol for multimedia. You want something else where all the control comes to me as the application developer and not on the network. Network gives me all these guarantees of in order, at most one reliable delivery. But for the application I'm looking at, I don't particularly care for all of those, so I don't really need those, right? Now, it's not always true. So if you're uploading a video to, say, YouTube, right, you want this kind of reliability, right? Because you're uploading, it's multimedia, but you're uploading. But when you're watching from YouTube, you don't particularly care if things are lost. You're able to adapt to that a lot better, right? But turns out, for a number of weird reasons, TCP is important for these kind of systems. The main reason is it's especially used in games for this reason. One is, for whatever reason, everybody has a router at home, right? It's a firewall router, right? I'm guessing most of you, when you have a home DSL or cable, you have a firewall, right? So the firewalls are cheap, right? They don't actually give you a lot more control on how to manipulate stuff. The cheap firewalls, what they do is they let all the traffic from inside to go out. They block all the traffic from outside from coming in, right? You can configure them to set up some zones and say this particular packet can go to this machine and all those things. But most people are not willing to do that kind of stuff, right? Most people set up these routers and leave it at the default setting. The default setting is it'll let you go from inside to do whatever you want, but it'll not let anything from outside to come in, right? And that gives you sort of like a protection from viruses and all those things, right? So for folks who play video games, right? How many of you play video games from like home? So do you have to mess with your firewall routers and stuff to let that game traffic go through, or what was the experience?
Yeah, I had to.
Yeah, so but some people can do that, but most people, they find that the game companies find that many people don't know how to do that, because EA, the routers are not capable of it because you bought a really cheap one which doesn't let you have the features. Or B, they don't know how to manage all the stuff because they don't want to let these things. So people are finding that TCP is a good alternative for playing video games, for the reason that it gets through firewalls a lot better than anything else, right? And so there's a lot of research on how to make video games play through TCP, right? It's pretty yucky because TCP is designed to have good efficiency, meaning TCP kind of buffers all the packets. So if you send lots of 1 byte packets, right, to say, I'm moving left kind of thing to the TCP. TCP is optimizing to be efficient, so it figures you are sending a lot of game to this game server, right? You're sending all this 1 byte stuff. I'm going to do the smart thing. I'm going to collect all of them. I'm going to wait for a second, collect all of them, make it into 1,000 byte packet or something. Then I'm going to send it off, right? Which is good from TCP's perspective. It's really awful from your perspective, because now it looks like you are even further on the network sense, because I sent a packet to the network, but nothing is going out of your home because it's being buffered, right? And sort of the reason is TCP is not designed for this kind of a thing, but people have to use this for game traffic. And so this issue, the development's trying to make TCP do some of this stuff. So this STCP and other efforts to streaming TCP kind of thing, but you don't give all the guarantees and still get sort of a good performance, right? The other notion is the UDP, which is the exact opposite of TCP in some sense. The idea here is I write some packets, they're delivered on the other end in a completely best effort sense, which means that there is no reliability guarantee that whatever I write would be received on the other end. There's no guarantees that whatever I write would be delivered on the other end in the order that I write. So if I write 1, 2, 3, you may get it in any order you want, right? And there's also no guarantee that it will only be received by you once, right? So for whatever reason they are duplicated on the network, so you may get 2 copies of something. So if I send 1, 2, 3, you may get 1, 1, 1, and 3, right? You lose 2, you get 3 copies of 1 kind of stuff. But the nice thing about multimedia is they're a lot more resilient to those, right? Because, for example, if you have a notion of frames, if I see 2 frames of the same, coming from you at the same time, I could throw one of them out. I may show them back to back. So instead of showing 1 frame, I now show 2 or 3 frames of the same scene. Most of the time, you can't really see what's going on, right? But the fact that the network is not getting in your way is really helpful. So you get lots of It's very good for multimedia, right? But it adds other aspects, which we'll see in the next slide, which is the notion of fairness. How do we deal with this stuff? And again, you might have seen some of these things from a networking perspective, but multimedia adds a little bit difference because of the strict requirements, right? So we're sort of getting near time, so I'll give a very brief overview of what this is, right? The idea here is the networks are all shared. So the big issue with networking is how to make it fair, right? Fair to you and fair to others. So the simple way of fairness is if you have m people wanting to use a network, the network has a capacity of n, I can sort of split it up into some fashion, right? And over m or some way to say, this person gets this much, this person gets this much, and all those things. And that would be sort of simple, and that would also be sort of wasteful because not all of us may want the same thing. So if you're talking about audio, right? If I'm receiving audio, if you're having audio chat, when you're talking, I'm silent. So why should I not receive more data and reserve the stuff for the back end? So what I would like to do is have these things fight each other out, right? And actually, I'd like to continue with that in the next lecture. And fighting each other out, it becomes pretty complicated. It's weird when you have multimedia, where it's aggressive than full UDP application, but not as aggressive as TCP. And how to manage those is something that becomes a problem. And I'll continue with that on Wednesday.